We have nice pulses, 4 to 10 pulses per minute. Need collect statistics long time. Statistics in 1 second intervals. We have from 4 to 10 or 12 counts, and the sum of clicks is about 500 times 77 minutes, average 7.2, and standard deviation is quite large. And yeah, so that's the neutron background, could be from cosmic background rays. Situation 1 day later. We have a strong gamma peak, then we have neutrons, but there are peaks at all energies possible. They could be from muons, which also ionize the gas in the cell. Gamma peak is very huge, almost 30,000 counts. Here is measurement setup. We have SNM3 boron trifluoride detector with high voltage cable, which is also signal cable. Then we have here resistor, which supplies high voltage, 100 megohms, and coupling capacitor, 30 picofarads. Here I have 2 stages of filter against high voltage ripple. High voltage is 2 kilovolts, and power supply is from AliExpress, the cheap one. It barely can give 2 kilovolts and overheats. And then I have preamplifier, and the analog signal goes to oscilloscope, and the comparator output goes to Arduino and display. This display shows time in minutes, and this shows how many clicks accumulated in the last minute. And clicks on oscilloscope look like this. Using SNM3 tube, it has boron trifluoride gas inside, and the reaction is when neutron reacts with boron and it makes alpha particle, and then detection circuit is similar to photodiode detectors or radon detectors in ionization chamber. The circuit prototype was suggested by Gamma Spectacular in Fusor.net forum for neutron detectors. About circuit which I built, there is high voltage capacitor which gets pulses through. Pulses are weak, about 10 millivolts in amplitude, because it is proportional counter. And then we have charge amplifier with feedback of 20 megohms resistor. After it comes out positive pulses, and they can be sent to oscilloscope or sound card. Amplifier bias is at half supply voltage of 5 volts. And then we go to comparator part, and it is also a stretcher. When a positive pulse comes here, output goes negative, it pulls this one negative to ground, and it takes time to charge it. And the level is set by variable 1010 potentiometer. And then the pulses are about 50 milliseconds long, and they can be sensed by Arduino analog input. Operation amplifier used first was TLE2072, but it is not rail to rail, so comparator did not work too good. And then I switched to LM6042.